Hello everyone, welcome to Data Popcorn. Today I would like to present on SQL Server statistics internals in 5 minutes. So here I'm using the database Stack Overflow 2013 and we are going to use users table actually, this user table and so we are going to talk about the SQL Server table statistics, right? So what are these statistics? Statistics are the plot structures actually inside the system tables. They actually describe the distribution of the data within your table columns, or the set of the columns are also not only the tables but also the views with the indexes, right? If they are inaccurate, then the execution plans will be affected and non-optimal plan will be generated. So these statistics are really important because whenever you run a query on the SQL Server, the SQL Server would always look for these statistics to predict how many number of rows it can generate as an output, right? So keeping these statistics up to date is really important. We all know that, right? But how to read these statistics? So for that, we are going to talk about DBCC show statistics, which will show the internals of the statistics, right? Inside the statistics, we have header, density vector, and histogram. So we are going to use this DBCC statistics on DBO users table for the reputation column. So let's run this on the database, Stack Overflow 2013 database, execute and see the results. Now there are three parts in DBCC show statistics, which is header, density vector, and histogram. Now let's talk about the header, right? Header contains the table column name. When was this column lastly updated? How many rows we have for this column and how many rows this column was sampled when you update the statistics. So as you see the equal value, that means it is 100% rows sampled. It is 100% up to date. So how many steps we have in this histogram? That is what it represents as steps 194. Now what is this value? For any histogram of the statistics, it can contain up to 200 steps, which is 200 rows. But if you are having any null values, then it can be 201 rows. But it can be anywhere below 200 as well. What is this density? Density represents how unique this column is actually, right? And then if you see the average key length and the string index and filters, do you have any filters on this particular column? We do not have because the unfiltered rows are same as the number of actual rows. That means it is unfiltered. Now, if you see the density vector represents actually, it is calculated by 1 divided by number of distinct values of this column. Now here you see the uh, one total number of distinct values in the column or the combination of the columns. Now if your statistic contains multiple columns, then it will take the combination of the columns, right? Now the lower the number, the highly unique it is. And if you see here, the lower the number, the highly unique. So it is like, it shows like 5.0, it is not that unique here, right? And if you see the histogram, this is the histogram. This is where it is very important to know these values. Range high key represents the column value itself. Like for example, here we are taking reputation column. So reputation column 1, reputation column number 3, not each and every value is represented here because histogram can only contain up till 200 or 201 rows, depending upon if you have a null value in that column, right? So it can't take each and every value. So it will take the set of values, right? Now for each reputation value number 1, we have equal number of rows of these many. For reputation value of 3, we have equal rows of 49,987 rows. That's the equal rows. Now what is this range rows? Range rows represents for the reputation value 1 and the reputation value 3, we have these many range rows, 1854 rows between these two values, right? Now, what is the distinct range rows? Distinct range rows represents, for example, I'm searching on the reputation column with the value between 1 and 3. Let's say for the reputation value 2, let's say. Now, how does the SQL Server will estimate the number of rows? It will actually take the range rows between these two values. This is the range rows, right? It will divide that with the distinct number of rows. So 1854 divided by 1 is 1854. This is the average range rows, which is divide this range rows divided by the distinct range rows will give the average range rows 1854. Now if you are searching in between these two rows, it will take this value as a estimate. But if you are searching with the repetition value 1, it will directly take the equal number of rows, and that is actually represented in your execution plan, the estimated number of rows. Now if you are searching on this value, now if you are searching on the repetition number in between these two, it will take the average range rows. That's how we read the um, in histogram value of the statistics. It is very important to always update the table statistics, and the sample you need to take, it can be up till 100%, but it depends upon your data and the distribution of the data, how your data is distributed within the column. There can be a lot of skew in your data, but it depends upon your workload, how much you will be sampling while updating these statistics. But they are really important while SQL Server go ahead and pull these values to make an estimate on how many rows it can estimate while pulling the data, right? So that is what it is in 5 minutes. I try to explain as much as possible about the histogram of the SQL Server statistics. Thank you so much for viewing.